Hello students. So today let us first recollect what we have discussed in yesterday's class and then we will continue with today's concepts, right. So here you can see that we talked about instantaneous rate of change, right, and we understood that it is just an idea. So and the way we defined instantaneous rate of change is, what did we do there? What we did was to develop a method to find the change in a very small interval of time to understand the concept of instantaneous speed, right. So to define the speed at an instant, so what we did was we took a very small interval, found the distance covered in that very small interval, divide it with that time interval, and whatever speed we got for that very small interval, we took it as the speed at that instant, correct. So that was what we have done, and we defined instantaneous speed as ds by dt. So this is something which you are not still aware of, so don't worry about it. So basically we understood instantaneous speed as rate of change of distance covered, correct, which is nothing but the slope of tangent drawn to the ST graph. So we have discussed in last class that the slope of the secant gives us the average speed between those two instants in that interval of time, correct, whereas the slope of tangent gives us the instantaneous speed. So this was what we have learnt in last class, right. So let us just see one simple example based on that particular idea, and then we can start off, right. So here they have given us the graph between distance covered by the body and the time, and as you can see they have given that this OA is a straight line and after that it is some random curve. So here we need to find speed at t is equal to 2 seconds and t is equal to 6 seconds. So let us say at 6 seconds if I draw a tangent, the tangent is making an angle of, let us say, some 30 degrees, clear. Okay. So we need to find out the speed at these two instants. So at t is equal to 2. How do we find that? If I take t is equal to 2 seconds, it would be over here, and at that point the graph is this. So it is on the straight line, clear. So we know that if I have to find the instantaneous speed, if they do not mention what kind of speed, you can, if they just mention speed, they mean instantaneous speed, clear. So at this instant and at this instant. So at 2 seconds if we see, so we know that to find instantaneous speed I need to draw a tangent, right. If I draw a tangent to a straight line, you all know that tangent to a straight line is a straight line itself, correct. So can I say that speed at 2 seconds is nothing but slope of this straight line itself, because this is itself the tangent, correct. So how do we find the slope of a straight line? You know that slope of a straight line can be found out by using y2 minus y1 divided by x2 minus x1, or you can say it is nothing but opposite by adjacent. So you can use any of these ideas. So if you know the coordinates, here you know the coordinates, right. So you can substitute the values of x1, x2, y1, y2, or you can just look at this length and divide it with this length. So if I do that, what do I get? So this length, or let me substitute the coordinates, right. You can easily say that this length is 15. So this length is 15 and this length is 3. So 15 by 3. So let us substitute the coordinates. You know that the coordinate of this point is 3 comma 15, right. X coordinate is 3, which is the time, and y coordinate is 15, which is the distance covered, and the other point the coordinates are 0 comma 0. So slope of line joining these 2 points is given by this. So I can write it as y2 minus y1 by x2 minus x1. So this will give me the value as 5 meter per second, right. So that would be the speed at t is equal to 2 seconds, clear. So similarly, if I have to find speed at t is equal to 6 seconds, if I look at the graph, so you can see that for the graph we have already drawn the tangent, and we can observe that the tangent is making an angle of 30 degrees with the positive x axis, right. So the tangent is like this and this angle is 30. The reason why I have drawn the line here itself is because even if I extend the line like this, it would still make 30 degrees. I guess you are all aware of this concept. whenever we have two parallel lines and if there is a straight line which is cutting through those two parallel lines, whatever is the angle here, same will be the angle here. Clear? So, if I draw a parallel line parallel to the x axis or the time axis here, so whatever angle that the tangent makes with the time axis, same will be this angle. So, I can directly take this as the angle made by tangent. So, what will be the velocity at t is equal to 6 seconds or speed at t is equal to 6 seconds? It is nothing but the slope of this tangent, which is tan 30, correct, and tan 30 will give you 1 by root 3. So, some of you might not have known this result for now. So, do not worry about that, you will soon learn it in your maths class. So, do not worry about that. So, just understand that we can find out the speed at any instant by finding the value of tan of angle it makes with x axis. Clear? So, that is the idea. So, after this let us see, I have told you that we are going to learn about the rate of change of any kind of function. So, yesterday we talked about rate of change of distance, which is speed. So, now let us talk about any kind of function, right. So, students, let us talk about the rate of change of a function. So, let us represent that particular function like this, y is equal to f of x. So, what we did yesterday was to take y as s distance and x as time, and we understood the concept of speed. So, now let us do a general, let us understand in a general way. So, how we do in maths, clear. So, if we have a function like this y is equal to f of x, let us consider some graph for that function also. So, this is y, this is x, and let us say it is represented on a graph something like this. So, this is how it is, let us consider, right. So, now we know that, as you can see from the concept of speed, we have understood that if I draw a tangent, I will be getting the rate of change of this function, right. So, like I told you, let us try to express it in mathematical terms. Okay. So, let us say, so for this value of input, let us call this as x, right. For this value of input, let us say this is our output, let us call it as y, right. Now, if I take one more input, so this one, let us call this input as x plus h. So, h being the difference between these two. So, if this length is h, so this input is greater than this input by h. So, x plus h, clear. And let us say the corresponding value of y here is what shall we take, or let us call this as, if this is x, y is nothing but f of x, correct, right. So, the output of this can be represented as f of x. Now, for x, if the output is f of x, for x plus h, what will be the output? So, we can write it as f of x plus h, correct. So, if I substitute x plus h into this, whatever y I get is the output there, right. So, now let us look at these 2 points. So, this is one point and this is the other point, correct. So, now if I draw a line which is passing through these 2 points, which would be like this. So, from what we discussed earlier, so we know that this line can be called as the secant, right. Now, let us write the expression for the slope of that secant. We know 2 points, we know the coordinates of those 2 points, I know the x, y coordinates of both the points. So, let us write the slope of the secant. So, if I write the slope of secant, what do I get? y2 minus y1 divided by x2 minus x1, or in simple terms I can understand it as, so this vertical length divided by this horizontal length, correct, opposite by adjacent. So, this length will be y2 minus y1, which is the difference of these 2 parameters, and this length will be the difference of these 2 parameters. So, if I write it, so I would be getting it as f of x plus h minus f of x, correct, y2 minus y1 divided by x2 minus x1, correct. So, now this is the idea of the slope of secant. Now, we discussed yesterday that whenever we calculate the slope of a secant, which is basically a line touching at two different points, the value which we get is not the instantaneous rate of change. What does slope of secant represent? It represents the average rate of change, correct? So, it represents average rate of change. So, that is the idea. So, what that means is, as I change my input from here to here, on an average, how much is the change in output, or per unit change in x, how much will be the change in y. So, this basically gives me an idea of average rate of change, clear. Now, like I told you, we are concerned, we need to know about the instantaneous rate of change, correct, and we already have an idea that instantaneous rate can be calculated. How can we calculate instantaneous rate? How do we make the average into instantaneous? By making sure that this secant eventually becomes the tangent at this point, correct. So, instantaneous rate can be found out by calculating the slope of tangent drawn wherever at the point wherever you need to find the rate of change, clear. So, I need to find rate of change at x, clear. So, what I have to do is I have to make sure that this point becomes closer and closer and closer and closer to x, I mean this value, in such a way that these 2 points eventually become the same point, correct. That was the idea. I have to make those 2 points so close that they overlap with each other, and the secant eventually becomes a tangent. So, whatever I have told you, whatever we have understood as words in words yesterday, that this point should approach this point and both of them should overlap with each other such that it becomes a tangent. So, that idea or that sentence can be expressed in a mathematical form, clear. So, it can be expressed as, I will write it down like this: instantaneous rate is equal to, which is nothing but slope of tangent, is nothing but f of x plus h minus f of x by x plus h minus x. Remember, this is the slope of secant. Now, how can I make a secant into a tangent? By bringing this very close. And how can I bring this very close? By making sure that the two inputs are very close. And when will the two inputs be very close? When h is very small, correct. So, what I am going to do here is something new to you. So, I am going to write a parameter here, please observe carefully, right. So, what I have written here is limit h tends to 0. So, that is how you should understand this. So, the way we read this is limit of that function, limit of the function when h tends to 0. Tends to basically means it approaches. I'll write that down also. Tends to basically means approaches. So, that is what we are looking for, correct. So, if I have to make this secant into a tangent, so tangent is basically the instantaneous rate of change, clear. Slope of that is the instantaneous rate of change. So, if I have to make this into a tangent, so these 2 points should be very close. When will these two be very close? When h is very small, correct. That is how we understood the idea of instantaneous rate. So, this expression which I have written here, instantaneous rate, is limit h tends to 0 y2 minus y1 by x2 minus x1. Just understand this as y2 minus y1 by x2 minus x1. So, looking at this, it looks like a very big expression, but actually it is not. It is just y2 minus y1 by x2 minus x1, as the separation between those two is very small. That is it. So, just understand it in that manner. And limit, calculating the limit basically means we are finding out what is this value approaching to when h approaches 0. So, calculating the limit of a function basically means, I will write this down here. So, you are not yet aware of the concept of limits, right. So, I will just give you an idea of what limit means. So, limit of a function is the value that the function approaches to when in this case we are talking about h, right, when h approaches 0. Clear? So, that is what it means. So, whatever this value becomes, whatever is this value as h becomes very small is the slope of tangent. So, this putting this limit h tends to 0, what is it making? It is making sure that this secant is eventually becoming a tangent, and we are calculating the slope of tangent. So, this is just a mathematical representation of the idea which we developed yesterday. The idea is the 2 points are very close, and the mathematical representation of that is this. So, making sure we write the expression for slope of the secant and making sure that h tends to 0, h approaches 0. So, is what makes it into a tangent, and slope of tangent is the instantaneous rate. Clear? So, this is the idea. So, this mathematical expression which we have written here, so we call it as the first principle of calculus. So, it is called as the first principle of calculus. So, which means the first rule. Clear? So, the idea is this. So, whenever we need to find the instantaneous rate, so the change at a particular instant, all you will have to do is draw a tangent, find the slope of the tangent, and slope of a tangent is represented mathematically like this. Clear? And as I told you, do not worry much about this limit idea. So, it is just a method for telling what is the value of this when this happens. Clear? When h is becoming very close to 0, what is this value? So, representing that is what we call as limit. Clear? So, nothing to worry about that, right. So, that is the idea. Now, this expression which I have written here can also be written in a slightly different form, right. So, think here I have told you earlier that this numerator is just y2 minus y1 by x2 minus x1, correct, and this h tends to 0. Make sure that this change in x, I have told you that if h is 0 or very close to 0, then the gap here will be very small, correct. So, such that this triangle which you see here, this triangle becomes very small. So, by the time I draw a tangent here, if let us say I am drawing a tangent, or let me draw the tangent in a different diagram. So, let us say it is something like this, and if I am finding the instantaneous rate here, what should I do here is I am going to take a very small gap. So, the gap should not be even this much, this is just for showing you I am drawing this much, but remember the gap should be almost 0, right. So, when I do that, although you can see 2 points, they are very close, they are the single point. So, the gap would be very small, right. So, this adjacent will be a very small length, and even the opposite will also be a very small length. So, this is change in x, and this vertical distance will be the change in y, right. So, this parameter as well as this parameter are very small values. Do you agree with that? Because the gap is very small, right. So, such small changes that are occurring in x and y is basically represented as dy and dx. Clear? So, instantaneous rate, which is this particular random expression, do not worry about this, can be understood as the small change in y divided by small change in x, that is it. So, the idea is that is it. So, in this case, if you observe, as these two become very close to each other, this is very small. So, this approaches dy, clear, as h tends to 0, this will not be this much, correct? It becomes very small. So, this is what we call as dy and this is what we call as dx. Remember, these two are when h approaches 0. Only when h approaches 0 this becomes tangent, and that tangent's slope will be dy by dx. So, that is it, students. So, it is a very simple idea. So, how we represent the slope of a tangent is dy by dx, small change in y by small change in x. So, that is the slope. So, this is the slope of tangent, and this method of calculating the slope of a tangent by using dy by dx, this is what we call as differentiation. Differentiation. So, that is the idea. So, differentiation basically means calculating the small change in y by small change in x, or differentiation means calculating the slope of tangent. These are all different ways of understanding the same thing, instantaneous rate, right, slope of tangent, differentiation, or dy by dx, all these represent the same thing. So, slope, what was I writing here? Differentiation is nothing but calculating the slope, calculating the slope of tangent. So, all these mean one and the same, all these sentences which I am writing here, all of them mean the same thing. What is that same thing? Finding out the slope of tangent at a particular instant. So, that is dy by dx, that is differentiation. We also call it as derivative sometimes, clear. So, the same idea, this dy by dx is also called as derivative. So, these are all terms which you should be aware of. So, derivative, differentiation, or calculating the slope of tangent, finding dy by dx, right, finding the rate of change or instantaneous rate of change, all these mean one and the same. I will write them down as a list so that it will be easier for you to identify, right. So, you can note this down. So, students, if you see here, so I have made a list of the different names which we give for the instantaneous rate of change. So, the instantaneous rate can also be understood as the slope of the tangent. It is also represented as dy by dx, the small change in y with the small divided by the small change in x, and that can also be represented by using this expression which we understood as the first principle of calculus, right. And so, in the denominator I have just written h. I think you know why, because it is nothing but x plus h minus x, right. So, it is just h, and it is also called as derivative, or this calculation of this process is also called as differentiation, and in fact there are other names also, other representations also. So, we can also represent this dy by dx, let me write it down here itself. So, this dy by dx or any of these things can also be called as f dash of x. So, f of x is basically the function. When you are differentiating it or when you are calculating the slope of the tangent of that function, we represent it as f dash of x, differentiation of f of x, clear. This can also be represented as y dash, just putting a dash. So, whether you put dash for y or for f of x, it means the same, you are finding the derivative, and that derivative basically means this dy by dx. So, these are all different ways of representing or naming the same thing, and what is that same thing? The slope of tangent or instantaneous rate of change, clear. So, that is the idea, students. So, now let us try to understand the rate of change for different types of functions, clear, the slope of the different types of functions, right. So, I will first take a function which is given by f of x is equal to, let us say, some x square. We can also understand that as y, right. So, y is equal to x square is the function. So, you know the graph of how the function looks like, right. So, this is how it is. So, this is y versus x. So, it is a parabola, right. Okay. So, now what we are going to do is to find out what is the slope of that function, clear, because you know that even the slope of this function is continuously changing. It is not a straight line, right. Straight line has a constant slope, whereas the slope of this, you can see that the tangent is making more and more angle with x axis as x increases, right. Okay. So, we are going to find out the slope now. So, we know that this is the method which we use, the first principle of calculus. So, that is what we will be doing. So, what I am doing now is calculating the value of dy by dx, which means small change in y by small change in x. So, we know this is nothing but limit h tends to 0 f of x plus h minus f of x by h. X plus h minus x is h, right. So, once again do not worry much about this representation, that is not at all required for us now, right. So, this only means that I need to find the value of this when h is very small, that is all it means. So, do not worry about the representation. Okay. So, let us do the calculation. I will not even write this limit h tends to 0 from now. So, let us say what is f of x plus h? If f of x is x square, can you say f of x plus h is nothing but x plus h whole square, correct, minus f of x. F of x is nothing but x square divided by h. Remember, we need to calculate the value of this function as h tends to 0, as h approaches 0. So, I am not writing the limit because you are not very much aware of that representation. So, let us say we need to just calculate this value as h tends to 0. Okay, let us do that. And see here, so when I expand this, you will be getting x square plus h square plus 2xh minus x square divided by h. We need to find this as h is very small. And I hope you are all aware of why I am writing this h tends to 0, because only when h tends to 0, the 2 points on the graph, if I take 2 points on the graph, so those 2 points will approach each other, they will become 1 point and we can calculate the slope of that tangent, clear. Okay. So, x square and x square gets cancelled, and if I divide this with h, so 1 h gets cancelled and here 1 h gets cancelled, and eventually I will get 2x plus h. So, as h tends to 0. Now, as h tends to 0, what will this value approach? Can I say that as h is becoming very small, this will be very small when compared to this. So, can I say that this value now approaches 2x, right, and that is the idea of slope of tangent, right. Slope of tangent is the value that the slope of secant approaches to, right. So, 2x. So, we say that 2x is the slope of this function or the derivative of this function. So, dy by dx can be written as 2x, clear students. So, that is the idea. So, we can also call this as this expression which I have written here, dy by dx, can be understood as differentiating y with respect to x, clear. So, that is the idea, students. Okay, now we got an expression once again. So, I got dy by dx is equal to 2x. We know that this is the slope, right. So, I have told you earlier that the slope of this function also continuously increases, and you can see that from the expression which we derived, slope is equal to 2x, which means as x increases, slope also increases, clear. So, this term which you see here, differentiating y with respect to x, so we can also understand this term as d by dx of y. So, what this means is, this d by dx is basically an operator, right. So, you know what an operator is. Operator is something which performs an operation, correct. So, d by dx can be understood as an operator. So, when you are putting d by dx in front of something, in this case y, so what you are doing is you are finding how the function varies with x, which means you are finding the rate of change of that function with respect to x. So, what I am doing here is, for example, let us say I am putting d by dx in front of x square. Clear? When I am putting d by dx in front of x square, what I am actually doing is I am finding out how is x square changing, how fast is x square changing when I am changing x. Please listen carefully. D by dx of x square means we are calculating whatever this value gives us, which we calculated as 2x. So, we calculated it as 2x just now. Clear? So, what this means is when I am putting an operator like this in front of something, what I am calculating is the rate at which this function changes as I change x. Clear? You can also write. So, now that we know that this is just an operator, you can use it for any type of variable. What I am saying is, for example, if I write d by dt of, let us say, t square, d by dt of t square will be once again a similar method, right. When I got d by dx of x square as 2x, I can write d by dt of t square as 2t. Clear? So, that is the idea. You can use any variable. So, d by ds of s square is 2s. Clear, students? So, that is the idea. So, this is basically an operator which calculates the rate at which this changes. Clear? So, you can view this like this, d by dx of something. So, if this is something, so what is the answer I am going to get here? So, if I substitute something here, let us say this is something, then what I am going to get here is the rate at which something changes with respect to x. So, let me write it so that you will understand. So, d by dx of something gives you, what is the result I am going to get here? Rate at which something changes with x, with change in x. So, as you change x, how does this something change? Clear? So, that is what you are calculating when you are putting this d by dx in front of something. So, please keep in mind. So, the basic idea is this, calculating the slope by using y2 minus y1 by x2 minus x1. Clear? So, that is all we have done. So, nothing special here. Only thing is that two values of y2, y1, x2, x1 are very close to each other. So, all these are just representations of that. So, what I am going to do now is I will give you a list of all the functions and their derivatives. Remember, all of them were derived by using the same method. So, I have shown you how to derive for one such case. Clear? If you want, we can derive for another case as well, we will see. But first, let us look at that table of functions and the corresponding derivatives, right. So, students, here you see a table. This basically gives you the list of different functions and their corresponding derivatives. So, derivatives in the sense the value of dy by dx, where y is f of x. So, if y is taken as f of x, in different cases we have, let us say in first case, if the function is a constant function, then the derivative of that is 0. Why? Why is it 0? Why is the derivative of a constant function 0? So, if you think logically, why is it 0? See that the definition or the meaning of dy by dx, what is it? Dy by dx means change in y divided by change in x. Very small change, right? Very small change in y divided by very small change in x. That is what we mean by dy by dx, correct? Now, when I change the value of x by a very small value, what happens to the constant function? It does not change, correct? That is why we call it as a constant function, correct? So, the change in y divided by change in x, the numerator part will become 0 in the first case. So, that is why we say that the derivative becomes 0, right. Okay. The second function, if you see, we are taking y is equal to x itself. So, when y is equal to x, can I say dy by dx is nothing but when I replace the value of y with x, I would be getting dx by x, which means change in x by change in x. Remember that this dx, d term here basically represents very small change, clear, infinitesimally small change. So, change in x by change in x is 1 itself, clear. So, this is 1. Similarly, for x square we have derived it earlier by using the first principle, and similarly if you derive for x cube, you will be getting 3x square, right. If you want, we can quickly do that derivation also. Let us see that. So, if I have f of x is equal to x cube, so you know that according to first principles dy by dx is nothing but f of x plus h minus f of x by h. We need to find the value of this function when h is very small, right. So, as h tends to 0. So, let us quickly substitute the values and see f of x plus h. So, in place of x, if I substitute x plus h, I get x plus h whole cube minus f of x is nothing but x cube divided by h, as h tends to 0, correct, as h tends to 0. Okay. Now, what is the expansion of this? What is x plus h whole cube? So, you know that it is nothing but x cube plus h cube plus 3x square h plus 3x h square, correct, minus x cube. So, this whole thing is the expansion of x plus h whole cube, right, minus x cube divided by h, and I need to find the value of this when h is very small. Okay. Now, this will be equal to minus x cube plus x cube gets cancelled, and if I divide this with h, I would be getting h square plus here h will get cancelled, you will get 3x square plus here 3x h. Yeah. So, this is the final expression which I would be getting. Now, remember I am calculating this value for very small h. Now, when h is very small, can I say that this term can be equated to 0, right, it is close to 0, and even this value here will be close to 0, right. So, I can neglect those two, and eventually I will be getting that as h approaches 0, this whole expression, this expression approaches 3x square, and whatever this value approaches is the slope of tangent, clear. So, 3x square is what we get there. So, which means from this we can understand that when I perform this operation d by dx of x cube, which means if I differentiate the function x cube with respect to x, I get 3x square, right students. So, that is what we have written here. So, please keep in mind that all the other results which I have given here are also derived in the same manner, but we do not need to go in depth analysis of each and every function. We just need to know the results here. We will be applying only those. You will be learning about these first principle applications in your maths in your second year. So, do not worry about that now. So, for now, this expression which you see here is a very important expression. We will be using this quite frequently, x power n, where n is an integer. So, the derivative of that function is given by n into x power n minus 1, right. So, whenever you have a function like this, then the power comes in front, and x power, the power this time will decrease by 1. So, whatever is the power, first multiply with that and then decrease the power by 1, clear. So, that is how we got this. You can see here. So, when I am differentiating x cube, so you see here I have brought 3 in front. So, 3 came to the front and x power 3 minus 1. So, you can understand this as 3 into x power 3 minus 1. So, that is what we got. So, you can even understand x square by using the same expression. What do we get? So, I should bring 2 to the front. So, 2 into x power 2 minus 1, 2 minus 1, 2 minus 1 is 1 itself. So, 2x, right. You can even understand this by using this, because x is nothing but x power 1, right. So, if I bring 1 in front, I get 1 into x power 1 minus 1. What is x power 1 minus 1? X power 0. X power 0 is nothing but 1. So, 1 into 1 is 1. So, that is the idea, students. So, the all the powers of x can be differentiated by using this expression. So, please keep in mind, this is a very important result, right. And similarly, if the function given to you is a sin x function, if it is sine, so if y is equal to sin x, then the derivative of that function is cos x. Clear? If the function given to you is cos x, then the derivative of that is minus sin x. So, please keep that in mind. For sin x, it is cos x. For if you differentiate cos x, you get minus sin x. Once again, all this can be derived by using that method. So, for now you do not have to worry about it, just keep these results in mind. Clear? Okay, so these are other functions which we will be coming across, but some of you might not have known what these functions are. So, there is no need to worry, you will slowly learn them once during your basic maths class, you will understand what these functions are. So, this is called as exponential function, this is called as logarithmic function. So, the derivative of a function in the form of e power x is e power x itself, and the differentiation of a logarithmic function log x to the base e will be 1 by x. So, for now just keep these results in mind, right. So, we are just understanding how to differentiate a function, right. So, do not worry about what do those functions actually mean, right. You learn one by one slowly, right. Students, now let us quickly write the derivatives of these functions which you see here. So, based on the table which we have seen earlier. So, I want you to pause here and just quickly write down the derivatives of these functions. So, let us see what the answers are. So, in the first case, for the first one, we can say that the value of y dash, I have told you that derivative can be represented as y dash. It is nothing but it can also be represented as f dash of x or dy by dx. Okay. So, what is the value of the derivative of the first function? 0, because that function does not change, it never changes. So, there is no meaning of asking what is the rate of change, correct. So, the rate of change of that function is 0. Okay. Second is x cube, we have just written the derivative of x cube. So, what is the method we use? First take the power, write it into x power to decrease the power by 1 now, right. So, 3 minus 1, so this gives you 3x square. Okay. Similarly, third one. Okay. So, third one if you see, so 1 by root x. So, you all know that 1 by root x is nothing but 1 by x power 1 by 2, correct. Now, it is not in the form of x power n, but I can bring it into x power n form, correct. So, which means I can write this as x power minus 1 by 2, correct. So, when I differentiate that, see, remember, for anything in the form of x power n, so n should be a real number, right. So, whenever n is a real number, so you can directly write it as n into, so I can bring this minus 1 by 2 to the front. So, that becomes minus 1 by 2 into x power, that power minus 1, right. So, which is minus 1 by 2 minus 1. So, what do we get here? So, this solving this will give me 1 by 2 into x power, what is minus half minus 1? Minus 3 by 2, correct. Similarly, so that should be the answer for that. So, fourth one, x power 5 by x square, you know how to deal with the exponents, right. When we are dividing, the exponents will get subtracted, right. So, this becomes x power 5 minus 2, which is x cube, and what is the derivative of x cube? We have already got that. So, we can directly write 3x square, 3 into x power 3 minus 1, right. Now, next one. So, sin square x plus cos square x. So, do not think that I do not know how to differentiate sin square x. So, I only know how to differentiate sin x. So, do not think like that, because this is just an identity, you must have studied that this is a trigonometric identity, right? Sin square x plus cos square x is always equal to 1, which means this is a constant function, right? So, and the derivative of a constant function is 0. Clear, students? So, that should be the answer. Maybe you can add one more function. So, let us say y is equal to root x. So, what is the derivative of root x? So, we know that root x is nothing but x power 1 by 2, correct? So, when I differentiate this, I get the method is same, bring the power to the front. So, 1 by 2 into, now decrease the power by 1, x power 1 by 2 minus 1. So, this gives us 1 by 2 into x power minus 1 by 2. So, that should be the answer, right. So, that is the idea, and now let us see the algebra of differentiation. I mean, how do we add or subtract, multiply or divide the derivatives, right. So, students, now let us see how to differentiate a function which is in the form of sum of two functions, right. So, if you have two functions f of x, g of x, which are either added or subtracted. So, this applies for both, either for addition or subtraction. So, when you are differentiating, when you are applying this d by dx, when you are differentiating sum of or difference of two different functions, then you can directly say that the result which you get will be the derivative of first function plus or minus the derivative of second function. So, you can separate them, you can apply the derivative for this separately and then perform the operation, whatever it is. If it is plus, add the individual derivatives, if it is minus, subtract the individual derivatives, right. Let us see an example. So, let us say I need to find the derivative of x square plus sin x, right. I need to find the derivative of x square plus sin x. So, what is the method we know? So, we know the derivative of this, we know the derivative of this, right. So, this is one individual function, this is another function. So, we can separate them out, find the derivative of each function individually and then perform the operation between them, which is sum, right. So, I can do this, I can write it as d by dx of x square plus d by dx of sin x, correct. So, d by dx means derivative of x square, derivative of sin x. Now, what is the value of this? You know this derivative of x square is bring 2 to the front into x power 2 minus 1. So, I am writing step by step, right. So, initially you also practice by writing each and every step. With practice you can directly look at the expression and eventually write the result for that. So, till you reach there, write each and every step. So, that will help you a lot. Plus d by dx of sin x. So, this is direct result, which is cos x, and simplifying this will give me 2x plus cos x. So, that should be the answer. So, the same thing would work even if it is a subtraction here, even if this is a minus sign here, you do the same thing, right. Okay. So, the next one, so the next rule, so this is one rule. So, the next rule is that whenever you have a function which is multiplied by a constant, so k here is a constant, and when you are differentiating an expression which is constant into a function, so what you can do is you can bring the constant out and then you can differentiate just the function and then multiply each other. So, once again an example for this, let us consider d by dx of, let us say 3x power 5, right, d by dx of 3x power 5. So, what should I do? So, if I apply this rule, the constant rule, we can call this as the constant rule of differentiation. So, what do I do now? Bring this constant outside. So, I can write this as 3 into d by dx of x power 5. Clear, students? So, this should be equal to 3 into, now differentiate this. So, what do I get here? When I differentiate x power 5, you know the method, it is just power rule, right, differentiating a power of x, and we can directly write it as, so bring the 5 to the front into x power, decrease the power by 1, 5 minus 1. What is the answer for this? 3 into 5 is 15 and x power 4, right. So, that is it. So, that is how we find out the derivatives whenever we have sum of two functions or when a function is multiplied with a constant. So, let us take an example based on this. Let us discuss one example. So, let us say we have taken a function which is given by, let us say y is given by 3x power 6 plus 1 by cubed root of x, right, plus 5 sin x or 5 cos x, right. So, we need to find the derivative of that function. So, as I told you, write step by step initially. So, once you get enough practice, you can directly write the expression. So, we are finding y dash. So, y dash is equal to, so let me first write it down. First, I will apply this rule, which is I can separate the derivative of this whole thing, d by dx of this whole thing can be written as d by dx of this plus d by dx of this plus d by dx of this, correct. So, first I will write that. So, I can write the whole expression into d by dx of 3x power 6 plus d by dx of 1 by cubed root x plus d by dx of 5 cos x, right. So, I have just separated it. I have used the first rule. Now, in this particular case, to calculate the derivative of this function, you see once again that it is in the form of 3, a constant into x power 6. You know that when I apply this concept, I can bring the constant out and then I can differentiate x power 6. Okay. So, that is what I will do. I will write it down once again, no need to hurry. So, let us write it step by step so that you know each and every step that is involved in this process. So, I can write this as 3 into d by dx of x power 6 plus what is this? I need to bring this into a power, right. So, what is 1 by cubed root of x? So, you know that cubed root of x basically means x power 1 by 3, right. So, x power 1 by 3 is what we call as cubed root of x. Now, 1 by x power 1 by 3 is nothing but x power minus 1 by 3. I can write this expression as d by dx of x power minus 1 by 3, correct students, right. Now, plus, now once again I can bring this 5 outside and write it as d by dx of cos x, right. Now, you can see that all these are basic derivatives which we had a table for, right. We know that these are all basic derivatives. I know how to differentiate x power 6 with respect to x. I know how to differentiate x power n, whatever n is, with respect to x. I know how to differentiate cos x with respect to x. So, that is it. We can just substitute the values now. So, I would be getting 3 into, what is this? Take the power to the front, 6 into x power, decrease the power by 1, 6 minus 1, right, plus here. So, take the power to the front. So, minus 1 by 3 into x power, decrease the power by 1, minus 1 by 3 minus 1, correct, plus 5 into the derivative of cos x with respect to x is directly minus sin x. So, do not forget that minus sign. So, that is very important. So, now what do I get here? 18 x power 5. So, 18 x power 5 minus, what do we have here? 1 by 3 into x power minus 4 by 3, right. I will directly write it here, x power minus 4 by 3, and there we have minus 5 sin x. So, that is it students, that is how we apply these two rules, right, clear. So, whenever we have additions or subtractions of two different functions, two or more functions, so you can separate them out individually, and whenever we have a function multiplied by a constant, bring the constant out, differentiate the function. So, that is the idea. So, after this we will talk about multiplication and division of different functions. So, students, now let us understand how to find the derivative when we have two functions which are multiplied with each other, right. So, as you can see here, so this is one function and this is another function, it is represented by f of x and g of x. So, when we are differentiating the product of two different functions, then the result that we should use should be this. See, these are some rules which you will have to remember, but once we do enough practice, you don't, it feels very easy. So, it looks very long and it looks pretty difficult to see, but it is very simple. So, how you should understand this is, if you consider this as the first function and this as the second function. So, what you see here is first function into derivative of second function plus second function into derivative of first function, that is it. 1 into derivative of 2 plus 2 into derivative of 1. So, that is the idea there, and keep in mind, so whenever we have something in this form, do not make the mistake of differentiating this and then taking the product of both. You understand what I am saying? See, if there was a plus here, which was the first rule, I told you differentiate this separately and add them, correct? But in product it should not be used. So, for product of two different functions, this is the method which we have to use, clear? So, if you ask why, so the reason of that, even this expression can be derived from the first principle of calculus, the limit f of x plus h, that function which we have seen. So, we can derive it from that, but as I told, we do not need that now. So, just understanding this relation is enough, clear? So, first into derivative of second. So, if this is f and this is s, I can understand this as first into s dash plus second into f dash. You understand what dash means, right? It is the derivative. First function into derivative of second function plus second function into derivative of first function. So, let us see an example, right. So, examples will help us understand better. So, let us consider this case. I need to find the derivative of d by dx of means derivative of what shall we take here, let us say x cube into cos x, x cube into cos x. Okay. Now, first of all, when you understand that this is a product of two different functions, first write down what those two functions are. This is one function, this is the other function. So, I am calling this as my f, this as my, you can call it as g or s, whatever. So, let us call it as s, right, first function, second function. So, now I have identified my functions, I will directly apply the result which we know. This should be equal to the derivative of product of two functions should be written as, first write the first function as it is. So, whatever is the first function, write it as it is, which is x cube multiplied by, now differentiate the second function. You know how to differentiate cos x, obviously with respect to x. What is derivative of cos x with respect to x? So, this is a direct result which we have been using, minus sin x, right, plus second. Now, second into derivative of first. So, second is cos x. So, I will directly write the second function which is cos x, and now I will multiply that with the derivative of first function. Derivative of first function, let me write it like this, d by dx of x cube. Or you can understand what we have written here is also the same, x cube into d by dx of cos x. So, this is what we have written there. Let me now expand this. So, I will be getting x cube into d by dx of cos x is nothing but sin x minus sin x, correct, plus cos x into derivative of x cube. So, you know this 3 first into x power 3 minus 1, which is x square. So, that is it, that should be the answer for that. So, the final answer would be minus sin x or minus x cube into sin x plus 3x square into cos x. So, that is it, students. So, when we have product of two functions, the idea is pretty simple. First into derivative of second plus second into derivative of first. So, remember it like that, everything will be simple to solve. So, let us see one more example, right. So, let us calculate the derivative of d by dx of let us say x square plus 2x, right, into root x plus 1 by x. Okay. So, by looking at this, it looks like a very complicated expression, but let us break it down. We know all the methods which we know which we need to solve this. We have already discussed the concepts required. So, if you want, you can try and you can verify once I give the answer for this. So, let us see. So, let us say this is the first function, this is the second function. So, I have already identified that my first function is this, my second function is this. I will write the solution here. Okay. So, I know that the derivative of that can be written as f into s dash plus s into f dash, correct. First into derivative of second plus second into derivative of first. Okay. Let me substitute. Let me do it step by step, right. So, that would be better for you. So, d by dx of, okay, first I should write f, right. So, what is f? F is x square plus 2x into s dash. S dash means derivative of this. So, I will write it down, d by dx of root x plus 1 by x, correct, plus, so this whole thing is the first term, which is this, plus now this one s into f dash, correct. S is this, I will write it as it is. So, which is root x plus 1 by x, correct, into I will write it here, d by dx of x square plus 2x. Clear, students? So, that is it. I have just substituted that in the actual expression. So, taking this as my first function and this as my second function. So, f s dash plus s f dash. Okay. Let me simplify this, x square plus 2x into, now look at this. So, I have derivative of sum of two different functions, correct. So, how do I do that? Differentiation of first, differentiation of second, and then sum of those two. So, I can write this as, should I write one more step? Let us write. So, d by dx of, what is this? X, root x is nothing but x power 1 by 2, correct, plus this would be d by dx of 1 by x is nothing but x power minus 1. So, x power minus 1, correct, plus this is as it is. So, root x plus 1 by x into this one, derivative of x square plus 2x. So, d by dx of x square plus d by dx of 2x, correct, students, right. So, this into this plus this into this, right. Okay. This should be equal to x square plus 2x into, now you know this, what is derivative of x power 1 by 2? So, I will write it as 1 by 2 into x power 1 by 2 minus 1, which is minus 1 by 2, clear, plus derivative of x power minus 1. What is that? Minus 1 should come to the front. So, minus 1 into x power minus 1 minus 1. So, which would be minus 2, correct. Now, plus, I will write this as it is, root x plus 1 by x into here, derivative of x square is 2x plus derivative of 2x, you know, product, the constant can be brought out, right. So, 2 times dx by dx or d by dx of x, which is nothing but 1. So, 2 into 1. So, derivative of 2x is nothing but 2, correct. So, that is the idea. So, you can leave it like that, there is no point expanding this, you know that this is the final answer which we should get, or if you want you can slightly simplify this, x square plus 2x into what is this? This can be written as x power minus 1 by 2 means what? 1 by root x, correct. So, this can be taken as 1 by 2 root x, right. X power 1 by 2 means root x, but there is a negative sign in the power. So, it goes to the denominator plus, sorry, we have minus, this can be written as 1 by x square, correct, plus this is as it is root x plus 1 by x into what is this 2x plus 2. So, that is it students. So, it might look very lengthy because we have expanded each and every step there, but I am very sure that once you do enough practice, if I give an expression like this, just by looking at the expression you would be directly writing the final step, but there is some time it takes for you to reach there. So, do not do it from the first itself, as soon as you see the question. So, do not be overconfident and try to write the derivative of this in the next step itself. So, initially as you are learning, so do it step by step, and with practice you will eventually get there. Clear students? So, that is the idea of how we should differentiate product of two different functions. Clear? Now, after this we will discuss about how we differentiate the quotient or the division of two different functions. Clear? So, students, for division, this is the rule that we will be using. So, when I am differentiating a function which is in the form of division of two different functions f of x by g of x, so the expression that I should use is this. So, once again it might look scary, but it is not actually, it is very simple. What we need to do here is first write the denominator, look at the denominator. In the denominator we have g of x whole square. So, whatever is the function we have in the denominator here, just square it and write it in the denominator. Clear? And in the numerator, if you observe, if this is first and this is second, second into derivative of first minus first into derivative of second. Clear? So, that is it. So, it means that if I have a function which I am considering as the division of u and v, u is a function and v is a function, clear, then I should write it like this. First write the denominator square in the denominator first, right, denominator is done. Now, when you look at the numerator, how do you understand the numerator? Second into derivative of first minus first u into derivative of second v dash, clear, that is it. So, you can remember this would be helpful, right. So, v u dash minus u v dash by v square, right. So, let us take an example to understand this. Now, find d by dx of, let us say, x by sin x. So, we need to find the derivative of x by sin x, clear. So, as it is, as we have done in the earlier case, we will first identify the two functions. So, this is u, this is v, right. So, let us do the simplification. So, in this case, as I told you, first write the denominator, let us get done with the denominator, then we will move to the numerator. So, if I look at the denominator, I have sin x. So, I will just square it and write it here. So, I will get sin x whole square, right. So, the denominator is done. Now, let us go to the numerator. So, where should I start with? Numerator is v u dash plus, sorry, minus u v dash, clear. So, v u. So, first I should start with v, so which is sin x into derivative of the numerator. What is derivative of x? Derivative of x is 1 itself. D by dx of x, d by dx of x is 1. So, into 1 minus what? So, now this into derivative of this, correct. So, x into derivative of sin x. We know that it is cos x. So, that is it. So, simplifying this will give me sin x minus x cos x divided by sin x. Sin x whole square is nothing but sin square x, right. So, this is the final expression which we would be getting. So, there are few rules which you should remember. So, there are 4 rules which we have discussed till now. One is when we have plus or minus, that is one rule. So, we can separately write and add or subtract them, and second one is the constant multiplying rule, right. Third one is the product, and fourth one is division. So, these are 4 rules which you will have to keep in mind, and you can differentiate any function which is given to you, right. Okay. So, let us see one more example. So, this time let us take an example like this. So, we need to find the derivative of, let us say, d by dx of tan x, right. Okay. Now, you might ask, where is numerator and denominator here? Why are you giving me this example here now? So, why am I giving you this example here? Because d by dx of this can be written as, tan x can be written as sin x by cos x. Now, we have 2 functions, one in the numerator, one in the denominator. Can you try? Can you try finding out the derivative of that? So, if I use the method, first of all I will get done with the denominator. I will have cos square x, cos x whole square is cos square x, and in the numerator, first I will start with cos x, I will write cos x into derivative of sin x. What is derivative of sin x? Cos x again. So, cos x minus, now numerator function which is sin x into derivative of cos x. We know that it is minus sin x. So, minus sin x. So, sin x into minus sin x, cos x into cos x, correct. So, that is what we get, and if you look at the numerator, we have cos square x minus sin square x, which becomes plus. So, eventually we will have cos square x plus sin square x. What is cos square x plus sin square x? 1, right. So, the final relation that I would be getting here is 1 by cos square x. What is 1 by cos square x? Do you know this result? 1 by, this is nothing but 1 by cos x whole square, right. What is 1 by cos x? What is inverse of cos x? Is secant x, right. So, this is nothing but secant square x. So, that is the answer, students. So, the derivative of tan x is secant square x, clear. So, you can use one more, you can solve one more example for this division method. So, let us take cosecant x this time, clear. So, d by dx of cosecant x. Okay. Once again, I have only a single function here, but I have given you this in the example for division. So, why did I give? You do not know the cosecant x derivative directly, I have not given you in the table earlier. So, I have not given because I was going to ask you here. So, what is the derivative of cosecant x? How do I do that? You know derivative of sin x. So, what can you do here is, I can write this as d by dx of 1 by sin x. I can write it. Now, I have a numerator and a denominator, and in the numerator I have a constant, and in the denominator I have sin x, correct. Okay. Now, I will once again apply the same method. First, I will write the denominator. Denominator will be square of denominator here, right. So, sin x whole square, and I should write the numerator with the second function which is sin x into derivative of numerator. What is the derivative of numerator here? What is the derivative of 1? 0, because it is a constant term. So, into 0 minus, right, numerator into derivative of this second function. What is derivative of sin x? Cos x. Clear students? So, that is it. So, when I simplify this, this is 0 minus cos x. So, I finally have cos x by sin square x. So, you can actually further simplify this. So, you can write this as minus cos x by, bring one sin x here and another sin x separately. Can I write it like that? I have just written the sin square x as sin x into sin x. So, what is the final result? Do you know what is cos x by sin x? Cos x by sin x is what? Cot x, right? So, that would be cot x into 1 by sin x. What is 1 by sin x? Cosecant x. Clear students? So, that is the idea. So, I would want you to derive whichever trigonometric relation which you do not know, which you are not aware of. You can use some methods like this, either make it as division of two functions that you know, or product of two functions that you know, and you can find the derivative of that function. Clear?